Hi everyone. Today we are going to see about broad approaches to migrating into the cloud. Yes, what is meant by migration? The word migration means we are moving something, information or data from one place to another, which is the thing have moved from one place to another is called as migration. What is meant by cloud migration? The cloud migration is a process of moving digital assets like data, workloads, IT resources, or applications to cloud infrastructure. This is known as cloud migration. That is, in the concept of IT sector, if you are moving the data of their particular companies or organizations into a cloud, is known as cloud migration. Next, why we are migrating? In business perspective, the cloud migration is allow the painless working of infrastructure, which is the applications and the data are grown without impacting business performances or customer experiences. If we have migrating the data to cloud, we can rectify or we can retrieve the data at any time, anywhere. So the cloud migration allow the business impacts and applications of the data without knowing the business performances of customer experiences. Some of the benefits of cloud migrations are it is more securable, scalability, integration, cost effective, and final owners and access. The next topic is a 7-step model of migration into a cloud. Here, what is meant by cloud migration? The cloud migration is a transformation from old traditional business operations to digital business operations, and the process of refers moving the digital business operations to a cloud. Introduction. In this cloud migration, we initiate into the cloud in some of the phases or in the stages. If migrating an application to a cloud is not an easy task because it is strictly adhered to 7-step model to ensure that the process is a robust and in-free solutions. This 7 steps carries how the data is required from the customer and how it is moved to the cloud and how it is approaching the cloud basis operations. The first one is a cloud migration assessment can compare some of the issues or requirement analysis involved in specific cases of migration at the application level or the code. It can be the design, architecture, or some of the usage levels. In addition, these migration assessments are done for tool-based where the test case as well as configurations, functionalities, and NFRs are used for the enterprise applications. Here, the migration can assess the issue based on some of the 7-step models. In this 7-step, it can access, isolate, testings, optimization, and maintenance, deployment. All the 7 steps covers the cloud migration assessments. The major 5 are represent the cloud migration strategy is are rehost, refactor, revise, rebuild, replace. The first one is a rehost. It is mainly referred to take the application to a new hosted cloud environment by selecting infrastructure as a service. Infrastructure as a service is nothing but they have already pre-planned their networks, services, storages, servers. That just we can push the application into the platform is known as infrastructure as a service. For example, if we are using the Gmail, Dropbox, these are all known as software as applications, software as a service. But the infrastructure as a service, it mainly utilizes the resource pooling and storage applications of the particular infrastructure. The second one is a refactor. It refers to reuse the application's code and frameworks and running the applications on platform as a service. Here, the platform as a service is nothing but we are using only the platform, but the application is developed by our own risk. Which means, for best example, is AWS EC2 tool. Here, this tool is mainly used to deploy the application, and it is used as and it is acted as backend of the platform where we can deploy our applications in the tool. So the best example for PaaS is an AWS EC2. The third one is an revise. It refers to expanding code base and then deploying it either by rehosting or refactor. If the code is expand or if the code is updating or by deploying some other requirements, it can move to the rehost or refactor. The fourth one is an rebuild. It refers to re-architecting the applications from the beginning on PaaS providers platform. Here we can rebuild the applications based on user requirements or some of the new informations or some of the new updates we need means we can push the application to rebuild. The final one is in replace. If we need any replacement of old applications instead of old application, we can use replace, which is mainly used to replace the old application with new ones. The best example is an SaaS, software as a service. The Gmail, Dropbox, Gmail, Photos, these are all comes under software as a service. The cloud-based application is already developed, or software applications are already developed. Just we are download and using. On this perspective, we are known as software as a service. The major seven-step model of migration into the cloud are: conduct cloud migration assessments, isolate the dependencies, map the messaging and environment, re-architect and implement the lost functionalities, leverage cloud functionalities and features, testing the migration, and the final one is then iterate and optimize. In diagrammatic representation, we have start the process from the axis, and the second one is an isolate, third one we are mapping, fourth one we are re-architecting, fifth one is an augment, sixth one is an testing, and final one is an optimize. We have ended the process on optimize stage. These are all the seven stages occurs in seven-step model of migration into a cloud. Each steps has different meaning and different approaches based on applications, cloud applications. The step one is the cloud migration assessments comprises the assessment to understanding the issues of a particular case of migrations at applications levels or coding, designing, architecting, or some of the usage levels. The main thing involved in step one is a return on investment. The assessments is about of cost of migration as well as about return on investment that can be achieved in case of some production version. And we can say pay as you go model. The based on this, the user or customer may don't worry about on their investment because what the level we are using the cloud storage, we can pay for that phase only. Step 2: isolating all systematic and environmental dependencies of enterprise application components within the captive data center. Here we can isolate some of the systematic and application components for some dependencies to store captive data center. Step 3: generating the mapping constraints between what shall possibly remain the local captive data center and what goes on to the cloud. The step 3 decides what are the information we need to hold on the particular server and which one can move to the cloud or data center based on their mapping constructions. Step 4: substantially part of an enterprise application need to be re-architect or redesigning and re-implementing on the cloud. On the based on that 5 hours, 3 hours can replace here. It is mainly used for the updation of the application or some of the information updated based on day-to-day services. Step 5, we leverage the intrinsic feature of the cloud computing services to augment our enterprise applications in its own small ways. Step 6. Here we can validate and test the new form of the enterprise applications within the extensive test suite that comprises the testing components based on enterprise application as well as cloud. The final one is an test results could be positive or mixed. It may be we can't predict that once we have complete the testing process, it shows whether it is positive or mixed result. In later case, we can iterate and optimize as appropriate iterations. The migration may be deemed successful. What are the migration risk and mitigations? First one is an intricate architecture. The second one is in multiple dependencies may cause. Third one is in data gravity. And the fourth one is in management and control of data streams within some of the heterogeneous environments. And fifth one is in cloud gravity. And the sixth one is in latency. And the final one is an architectural difference. The short summary of the 7-step model of migration into the cloud is an first step is an access. Here we can evaluate the application, or we can check the cost and the benefits of the applications and decide if the cloud moving some of the informations which can fit into the server or not. And the second one is an isolate step. Here we can find the application dependencies and we can separate some of the connected database, and it creates some clear boundaries. The third one is a mapping. Here we can plan the cloud setup and match old servers to accompany the new cloud servers. Here the automation can be takes place, which is an auto scaling, where the server filled by informations or data, it can automatically move to the new servers, and it can direct how data travels between the servers and the cloud. And re-architect, here we can modify the old code, or we can fix some of the features broken or not, and we can rebuild some of the parts to the cloud. And the sixth one is an augment. Here we can add some of the modern cloud features, or we can include some automatic scaling, or we can improve some applications performance based on re-architect or cloud broken features. And we can test here. Here it can run the new cloud applications, check for bugs, compare speed with the old versions. And the final one is an optimize. Monitor can active cloud costs, clean up waste resources, and finalize the loop. These are the 7-step model of migration to the cloud. The next one is a small video. Here it shows how the world moving to the cloud environment. Yes.
Everyone benefits when healthcare is smarter, more collaborative, and cost-effective. Amazon Web Services provides cloud-based technology services and solutions designed to power innovation. Whether you are a healthcare provider or insurer, AWS helps you address key needs. Patients want interactive healthcare, and AWS powers services that providers can use to engage with patients, share meaningful information in a private and secure manner, and empower patients to manage their own care. Providers want access to new technology, allowing them to make data-driven decisions. AWS helps transform data into insights through advanced analytics, permitting providers to focus on delivering high-quality care. Healthcare provider and insurer organizations want to provide clinical and operational solutions for their teams while improving data security. AWS has scalable and secure HIPAA-eligible services that enable innovation, all while reducing complexity, risk, and costs. Across the healthcare industry, AWS has an ecosystem of partners working with organizations to develop services like advanced machine learning to help predict potential health risks, develop personalized medicine, and coordinate care, improving outcomes for patients around the world. AWS provides secure, cost-effective, and scalable solutions, creating a smarter, more collaborative, and affordable healthcare experience. Learn how others are using AWS and AWS partners in healthcare.
In AWS, how we can use the seven-step model means first one is in cloud requirement analysis, and the second one is in AWS cloud and IAM setup. Third one is a network configuration. Fourth one is an compute setup, which is an EC2 or Lambda. And the fifth one is in storage and database setups. And the sixth one is an application deployment and security. And the final one is in monitoring, optimization, and maintenance. In this AWS cloud, how the seven-step model can occur means first one is in requirement analysis. Here we can find the number of users, types of applications, and extended some of the traffics or amount of data and availability of requirements, budgets. These all comes under the first phase. The second phase, which is we can use AWS account and IAM setup. Here, once the requirements are understood, we can establish the AWS environments. Based on this concept, the identity and access management controls who can access the resources and what they are allowed to do. These users can represent an individual identity. The third one is a network design using VPC. Here the primary AWS services can be used, which is a virtual private cloud VPC connectivity. Here we can logically isolate the network environment, which is in a subnets, route tables, internet gateways, security controls like that. The subnet is a small network inside a VPC. It is nothing but public, private, or we can use either public or private. The structures comes under public subnet applications or private subnet comes under database. Then next one is an internet gateway. Here it can allow communication between the VPC and the internet when routing and security rules permit it. Some of the compute resources, like after creating the network, we need to compute resources to run our applications, and here the AWS provide multiple compute options, and EC2, which is an elastic cloud compute, mainly used to choose operating systems, CPU, memory, storage, and security groups, and finally the network configurations. How EC2 instance will give the structure as OS, then second comes follows application, and then follows as CPU, and follows as memory, and final one is an storage. For example, first we are creating EC2, then installing some languages as Python, and installing application dependencies, then uploading the application, then start web servers, then application become available. Then the storage and database are mainly used to store the objects, which it may be either images, video, or documents. And application deployment, here the application can be deployed based on application code, building or testing, deploymenting, AWS compute, and application running finally. Otherwise, for example, developer, some Git repositories, we are building or testing some of the applications, then EC2, and we are pushing the applications into it. The final security conception, we have seen security groups to control traffics on the resources, and encryption. Here it protects the data, and HTTPS means we can protect communication between user and web applications. Monitoring, scaling, and optimization. The final one is here we can monitor the CPU utilizations, memory related matrices, application logs, request counts, errors, and the final one is an alarm application. Here the scaling can suppose 1,000 users, but during examination result, if suddenly increases to 50,000 users, the infrastructure maybe need to handle the increased demand, right? So we are using cloud architecture scaling mechanisms to increase the capacities when it required. It is known as elasticity. This elasticity is an ability to adjust the resources according to the demands. That's all about today's class. Thank you.